Okay, section 29 of the notes is for a lot of students very difficult conceptually. We try to boil it down to very simple visualization. But again, I want to point out that if you really think about moving forward in an educational environment, you're going to have to do more than just the minimum, which is basically, I just want to know what the minimum I have to do. And we really kind of boil things out of very simplistic ideas. I would say if you're thinking about becoming more engaged with your studies, you really need to start reading textbooks. All right, you really need to start doing that. Unfortunately, a large part of people's education nowadays are basically what's training, and training is basically someone, it's almost like you're in a factory and you're doing the same thing over and over again without any understanding of the bigger picture. And this is the part where we're talking about these definitions that we're gone through in the lecture portion. I know they're tough, no doubt about it, right? Like if you think you're having trouble with this, we repeat this in 119. We repeat this in courses that go above this as well. We keep repeating this stuff over and over again, and it gets a little tedious over time. But the bottom line is it's really something we can boil down to a very simple visual problem. And that's what we're going to do. We try to make the problems really, really simple. All right. As we make the problem simple, I want to encourage you that you would need to reinforce this by doing other simple problems to reinforce what we're talking about. Now, granted, you may want to read through this stuff again, watch the video again, watch the lecture again, blah, 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 blah. What we need to do is we need to get to the examples. All right. As I do the examples, again, if you're seeing a different teacher or a tutor, they might do them differently. But the bottom line, I'm going to write this down the way I do it in classroom. All right. I'm going to do another share with you. And give me a second to do so. And let me see, get this sharing with you. And I'll take a look. I'm going to look at problem number one. And number one says state whether the relation, and it's a relationship, by the way. I want to tell you what the relationship is. There's a set of ordered pairs, and the ordered pairs have a relationship. For example, X is related to Y. All right. So typically, I'm going to emphasize what this X is, an ordered pair. This is going to be the domain. And this is the range number over here. It's in the range. All right. Now, when I put the relationship down, I know the relationship. For example, the first point says -9 is related to -7. Then it says -7 is related to -2. Then it says -2 is related to 0. And then it says 0 is related to 4. So let me write down the domain numbers for you. All right, I'll put the D down for you. Now, someone says you're delaying the inevitable, answering their question. Well, we're just reviewing. That's all we're doing. So what are the domain numbers? -9, -7. These are the X numbers. -2 and 0. And what's the range numbers? I'm write them down for you. -7, -2, 0, and 4. All right. So, we can go back and read the definition to you, but the bottom line is the way we've been doing these problems over here is we've been doing what's called a bubble diagram. So we put a bubble here, and this bubble over here is the set A, or the X is in the problem, or the domain of the problem. Now, this, generally speaking, is not doable, but I think this is doable. I can write these numbers down now. What's in the domain? -9, -7, -2, and 0. Let's put the next bubble down. And we call this the set B, or the Y values, or the range. What's the range? Well, let's write this down. -7, -2, 0, and 4. Now let's talk about how they're connected together. -9 connects to -7. -7 connects to -2. -2 connects to 0. 0 connects to 4. Now, I want to point out, for some students that can't remember that, I want to put what we're talking about. We're talking about what was given us to us. So -9 goes to -7, -7 goes to -2, -2 goes to 0, and 0 goes to 4. Now, what we've got to make sure of is that everyone in the domain has an arrow coming from it. Check, everyone does. The next thing we must check for functionality is that every number in the domain only has one arrow coming from it, and that's done. So the answer over here is yes, this is functional. The bubble diagram tells me that. So what's my answer over here? Yes, it's functional. Let's go to number 2. Same story. I'll write it down for you. What's the story? There's a domain in the problem. I'll write this over here. What's the domain? I'm reading it to you. It's going to be 4, 0, 6, and 7. So where are you getting those numbers from? Looking at the ordered pairs. It's the X numbers, 4, 0, 6, and 7. What's the range? It's a set of numbers. -3. This is the Y value, is the second number. 0. Well, someone says, oh, 0 is down twice, put it down twice. No, it's 0. It's there. And what else? -3. There's only 2 numbers. Well, I'm going to put my bubble diagram down again. Put this over here. This is going to be the set A, where the X's, also called the domain. And what's in the domain? Let's write it down. 4, 0, 6, and 7. Now I'm going to put the set B down, which is Y's. By the way, it doesn't have to be Y's, but, and this is also called range. Now, this thing over here is, what numbers are there? I'll write it down for you. -3 is there, and 0 is there. Well, what I'm going to do is I'm going to see, how are they connected, right? How are those numbers connected? I'm going to look at it. 4 is related to -3. That's fine. 0 is related to 0. 6 is related to 0. And 7 is related to -3. What am I looking for? And I'll repeat this to you. Every guy in the domain has to have an arrow coming from it. And that's true. The next statement is there's only can be one arrow coming from everybody in the domain. Well, look at it. There's only one arrow coming from everybody in the domain. So this is also functional. Let me just push that over. Make sure you know what I'm talking about. Whoops, I went too far there. Yes. Whoops, I did it again. Yes. All right, let's do the next one. Move this over a little bit. And I think you probably know what I'm going to do. I'll put domain down again. This is number 3 now. I see 4. I see 2. These are the X numbers. 6, 7, and I see 2 again. I'm not going to put it down twice, by the way. I see 2. It's like you see me early and then later in the day, I'm still the same guy, right? 4, 2, 6, and 7. You put the range down. And what's the range going to be? -3, 0, -4, -2, and 7. And I think I'm going to put a bubble diagram down, right? Put this over here. This is going to be A, the set A. This is set B. This is domain. And this is the range. This is also the X values in these particular examples and the Y values in these particular examples. So what's the domain? Let's write this down for you. It's 4, 2, 6, and 7. What's the range? -3, 0, -4, -2, and 7. Let's talk about the relationships now. 4 is related to -3. 2 is related to 0. 6 is related to -4. 7 is related to -2. Right? And last but not least, you have 2 again. And who's 2 related to? 7. All right, I got troubles. Someone says, what are the troubles? Well, everybody in the domains map with somebody. They got arrows coming from it. Unfortunately, 2 is a violation. And why is that? They can only have 1 arrow coming from it. So this guy is trouble, right? 2 is going to 2 different places, 0, and it's going to 7. So this is a resounding no. This is not a function. All right. So look at the key. It says no. And what does it say? There's an element in the domain, which is 2, that maps the 2 different numbers in the range, and it maps to 0 and 7. Bad news. All right. Look at number 4, and I'll take a look at it, and I'll try to understand what they're asking me to do. But number 4 looks like an easier question for me. When I use this notation over here, I'm saying f of x. I'm saying f is a function of x, and a function is 4x minus 3. Now, what do they want me to do? Evaluate f of minus 3. My recommendation is to parenthesize the variable and plug in its value later, which is minus 3. What do you get there? Minus 12, minus 3, which is minus 15. All right, let's do the next one, number 5. Very similar type question. This is a function called g. G is a function of x. And what is that function? It's x squared. Let's see, minus 3x plus 2. What's g of minus 2, though? Parenthesize the variable and plug it in. And what do you get? 4 plus 6 plus 2. Well, 4 plus 6 is 10, and 10 plus 2 is 12. Okay, not so bad. Let's go to the next one. Number 6. Now, for some people, they look at this, and say, why are you using different letters? It happens in math, and it happens a lot. All right. So what I claim over here, I'll just write it down. And they're saying that k is a function of the letter y. Put this down, y minus 2 over y plus 2. Now, what do they say? Evaluate k at minus 1. Well, you know what? I think I get a little better at this. And so if I did the top, what would you get? Minus 1 minus 2 is minus 3. And minus 1 plus 2 is 1. And what does that give me? Minus 3. Feel good about that. All right, let's do this one over here. Find the domain and range of the function. Well, we've been doing this for some time now. Let's write it down. By the way, say other function. I guess they're indicating this is a function. Eight, 10, 6, 5. It's the first number in the ordered pair. 8, 10, 6, and 5. What's the range? It's the second number of the ordered pair. Minus 5, 7, minus 1, minus 3. Let's get our grade key out. See how we did. 8, 10, 6, 5. Minus 5, 7, minus 1, minus 3. We did okay. Let's keep going. We're on a roll. Let's do number 8. What does number 8 say? What values are excluded from the domain? Well, remember, domain in this case over here are these numbers. These are domain numbers. It's what's coming into the problem. I've got troubles. Let me point out what the trouble is. I have a division. I can never divide by 0. So x minus 2, if it becomes 0, this is a very dangerous number. So what number is it? It's x equals 2. So the number that's excluded is 2. X can't be 2. Why is that? Division by 0. So the number being excluded is 2, because I can't divide by 0. Let's go to number 9. What's nice about number 9? It looks difficult, but it's not. Let me point out what's happening over here. This is a domain. It's the numbers coming in. What's their question? What numbers are excluded? So what am I looking at? I'm looking at this thing over here. I don't see any divisions, and they're the big troubles we have, right? There are other troubles like even roots, but right now divisions are big trouble. I see no divisions, so I'm going to say no one is excluded or none. Look at your answer key, and no one's being excluded. All right, let's take a look at the next question, which would be number 10. Oh boy, number 10. All right, problematic. All right, so I want to point out what the domain means. The domain is the X values. This is what's coming in. Then what happens is X operates on these things. I'm sorry, H operates on these things, and it pumps back what's called a range. What's their question? Find the range given the domain. What's a domain? It's these numbers. So this one, this one, this one, this one, and this one. I got to do one at a time. Let's put this down. So I got to put down H of -9. I have to do H of -6. I have to do H of -3. I have to do H of 0. And I have to do H of 3. One at a time. And I got to be honest with you, I think it looks pretty easy to do. And the reason for that is it's just 7 times the number -2. So let's write these down. I guess I want to do 0 first. This would be 0 -2, which is -2. Let me do 3 next. That's 21 -2, which is 19. You may wonder what I'm doing. I'm doing 7 times the argument. Well, 7 times 3 is 21, and 21 minus 2 is 19. Now, 7 times -3 is -21 -2. That's -23. Now, 7 times -6 is -42 -2, which is -44. 7 times -9 is -63. -2 is -65. So I know my range now, and I'm going to write it down for you. The range is a set of numbers. And what's it going to be? I'll write it down. -65. We'll look at the key later. -44. -23. -2. And 19. Let's look at our key. See how we did. Mistakes happen, by the way. All right. Let's go to the next question. Number 11. Doesn't look so bad. They got an answer key for me. Well, I'm going to recommend parenthesizing the variable and plugging in. What would that give me? Well, it looks tough. Not really. It's an easy number, right? 1 plus 3 plus 1, which is 5. Bingo. All right. I got trouble with the next one. I'll tell you why. If I write the letter S down, whoops, I didn't mean to do that. If I write the letter S down, it looks like the number 5. That's not good. So what I do instead is I use a cursive S. I'll put this down for you. So I write this down as F of the cursive S. Parenthesize the variable. And now plug in the cursive S. What do you get? S squared minus 3S plus 1. Bingo. Let's do the next one. That's F of 2x. Parenthesize the variable and plug it in. What do you get there? 4x squared minus 6x plus 1. Check the key. All right, this is getting tough now. and I'm gonna pull on the side. So I'm gonna put this one over here. And it's a bit more difficult for me. So it's f of a plus b. Parenthesize the variable and plug it in. That's a plus b, right? I know for some students, it's very frustrating now. I say, do I need to do that work? We would like you to try. So if a plus b squared would be a squared plus 2ab plus b squared minus 3a minus 3b plus 1. All right, I'm going to put a box in that. I'm going to check it. A squared, 2ab, b squared, minus 3a, minus 3b, plus 1. Working beautifully. All right, E's a killer. All right, I'll write it down for you, though. But maybe, I was going to say, if you can write something down, there's a chance you might be able to do it. And I'll write this down for you. So what does it say? F of a minus f of b over a minus b. And you know what? I've been doing this, I think I can remember what the function is. Well, f of a would be a squared minus 3a plus 1 minus f of b, b squared minus 3b plus 1 over a minus b. Now I realize sometimes, oh, that must be the answer. I'm looking at it, and that's not their answer. Let's keep working. One step at a time. A squared minus 3a. Well, the ones disappear, right? Hope you see that. 1 minus 1 is none. Let's keep going. Minus b squared minus a minus 3 is plus 3b over a minus b. Well, let me look at the answer. That's still not their answer. They must have done something else. Let's keep moving. And by the way, I understand people get frustrated and say, I can't go on. Your goal is to move forward. So I'm going to put down a squared minus b squared minus 3a plus 3b. Someone says, why would you do that? I'm thinking that maybe this factors by grouping. Have we done that before? Of course we have. So I want to factor this guy here. That would be a minus b times a plus b. And then I want to factor these two guys over here. And what pulls out from that? Minus 3. And what do you get? A minus b. We get on bottom, a minus, whoops, I'm sorry about that. It's just a minus b, and I'll factor that. All right, I'm going to keep going. It's still not the right answer, by the way. I'm going to look at the top. And what about the top? They have a factor in common as two terms, which is a minus b. And what are you left off with? A plus b minus 3 over a minus b. What cancels here? These cancel. What are you left off with? A plus b minus 3. Now, a lot of students, that's just too much work. Let's take a look at the answer. It's the answer. You want to work towards that goal. All right, let me repeat this about the homework. Homework follows from what we've just done. You need chance to practice to see if you can handle it. If you can't handle it, after practicing and studying, you are to come by during office hours, and we will be more than happy to help you. The problems that follow, though, like 1, 2, yada, 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 really are just the same problems that we just did. Hopefully you can study that material and get good at it. And that's what we're hoping for. Thanks for paying attention.